Okay, as a quick review before we get into today's lesson, we're just going to go ahead and graph the parabola here. Number one, the parabola, remember, is in standard form. So just looking at it in standard form, I don't know what the vertex is. You're going to have to do a little bit of work to figure that out. So we're going to use our axis of symmetry to do that. And remember, we have this little formula, x equals opposite of b divided by 2 times a. So that's going to turn out to be -4 divided by 2 times 1. So that's -2. So your axis of symmetry is at -2. That also means I know my x value of my vertex. So my vertex is -2. And anytime you know an x value, you're just going to plug that back into the original equation, and that will tell you a y value. So we're going to go a -2 squared plus 4 times -2 plus 3. So 4 plus a -8 is -4 plus 3 is -1. So my vertex here is at -2, -1. I'm going to look right here in front of the x squared. Right here is where I look for the a to see if there's any stretching or shrinking. There's no stretching or shrinking. So that means then our pattern, vertical pattern, remember on this one, our vertical pattern is 1, 3, 5, 7, and our horizontal pattern is always over 1. So we'll just go up 1 over 1, up 3 over 1, up 5 over 1, and now we're off our graph paper. Okay, so there's a sketch of that parabola right there. All right, over here, number 2, you could look at number 2, and you could think of number 2 as either vertex form or standard form. When I look at it, I kind of see vertex form. I'm kind of thinking it looks like this, x minus h squared plus k. Even though I don't see parentheses, I know that since there's nothing added or subtracted from the x squared, that really what you have is a 0 there. So that means your vertex is 0, 5. So I like to think of that as vertex form. You could do the axis of symmetry like we did on the one on the left, and you'd still get the same answer. So 0, 5, 1, 2, 3, 4, 5. My A is 1, so my vertical pattern is still 1, 3, 5, 7. Nothing is changing, so I'm going to go up 1 over 1, up 3 over 1, and I'm off my graph paper. So there's that one. Okay, this one right here is already in vertex form, so that's really nice. We can look at it right here and get our h and our k. So this is at 2, 4. So I'm going to go over 2, up 4, 1, 2, 3, 4. I notice that there is an a value right here. It's negative, so that means my parabola is going to open down. And it's a 4, so it's going to be stretched a lot. So that pattern 1, 3, 5, 7, we're going to multiply that by -4. This parabola is going to be really skinny. So this is going to be -4, -12, and I'm pretty sure we'll be off our graph paper by then. So we're going to start here, and we're going down 4, 1, 2, 3, 4 over 1, and then down 12, which is off our graph paper. 2 more spaces off our graph paper. I'll just kind of guess right there and maybe right there. And so then we'll sketch that in. Try to keep it rounded. So there's that graph. Okay, once again, this one also, I noticed that it's in vertex form, which is my favorite because I can just start graphing. And my A is a -2. So my vertex right here, whoops, here's the vertex right here. So this is 2, 8. So over 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. We're going down because it's a -2. Here's our vertical pattern, 1, 3, 5, 7. We're going to multiply that by -2. We're going to stretch our graph, and it's going to be skinny. So we're going to go down 2, down 6, 6. And then we're going to go down 10, and then you're off your graph paper. So down 10 over 1, and then we'll make a sketch there. Okay, so that's reviewing. We did this before the break, graphing of the parabolas in vertex form and in standard form. Today, we're going to learn the last form. It's called intercept form. So just like the title of its form, intercept, what you're going to be found, what it's going to give you is your x-intercepts. So this P right here and this Q right here represent the x-intercepts. It represents where your graph crosses the x-axis. So if we looked over here on the previous page, we have x-intercepts right here, 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 here on those two. So this equation right here in this form is going to tell us where it crosses the x-axis. So it's not a vertex. It's going to tell us where it crosses the x-axis. So in this particular problem right here, we've got y equals a negative 2, x plus 2, and then x minus 4. What I know from this is x is going to equal negative 2. And from this parenthesis, x equals 4. So what it's telling me then is negative 2, 0 is an intercept, and 4, 0 is an intercept. And my A is negative 2, so my graph is facing down, and it's going to be stretched. It's going to have a vertical stretch. So it's going to look a little thinner. It's going to be a little thinner. Okay, so here we go. We've graphed those two intercepts right here. It says if all we know are the two intercepts, how will we know if the graph opens up or down and what the vertex is? Okay, well, we just talked about how it can open up or down from right here. Here's our A. I know it opens down. So I know this one is opening down right here because A is negative. We've graphed the two intercepts. Now remember, a parabola, when you graph this quadratic, the parabola shape is symmetric. So you should know where your axis of symmetry is. So if I were to look at P and Q, they seem to be 1, 2, 3, 4, 5, 6 spaces apart. So the middle would be right here at x equals 1. That's my axis of symmetry. Okay, that's going to help me find my vertex. Remember, your vertex, just like in standard form, has to be on the axis of symmetry. So my vertex is 1. And remember, anytime I know an x value, I can find the y value if I plug it back into the original equation. It doesn't matter what form your original equation is. You just need to take and put 1 in for x. So I'm going to say y equals negative 2, and then I'm going to go 1 plus 2, and 1 subtract 4. Okay, order of operations, I'll do what's in the parentheses first. So that's 3, and 1 subtract 4 is negative 3. And now I'll multiply those 3 together, and that's going to be 3 times 18. It's 18. So my vertex is at 118. Now, this is definitely off my graph paper, so I have two choices. I can either rescale my y-axis, count it by 2s, then I could get my graph on, or in your homework, there's going to be quite a few that the vertex goes off the graph paper. And the problem is once we start our graphing, we start the x scale, we just start counting by ones, and then we realize our y scale probably isn't going to work. I will let you, as long as you label your point up here without rescaling, we'll just make a sketch that's not to scale. We'll call that vertex 118. Make sure you label it. And then since you have the two x-intercepts and you know where it's going to graph, you can just sketch the parabola through those points. That definitely is not to scale. It's not proportional, but it wouldn't be to scale even if we counted our it would be to scale. It wouldn't be proportional if we changed our y values, counted them by twos. It still would look a little skewed. So you're going to have to remember that your parabola's shape, you still want it to be curved, but it's actually not going to be the exact shape it should be if we can't get all of the points on the grid. Okay, let's try another one. So it says find the intercepts and the axis of symmetry, decide whether the graph opens up or down, graph, and find the domain and range. Okay, so this one right here, first thing you have to do is recognize what form you're in, and this is in intercept form. This is telling me that my x equals -2 and x equals -6, so my intercepts are at -2, 0 and -6, 0. So when I come over here at -2, 0 and -6, 0 and put my points, I know by looking at my A right here that my parabola is going to open up. It's a +3. I just don't know where the vertex is yet. But I do have x-intercepts. I do know that a parabola is symmetric, so I know this is my axis of symmetry right here. And so my axis of symmetry is going to be at x equals -4. So that tells me my vertex has to be at -4, comma, and remember, once you know the x value, you plug it back in to find the y value. So y equals 3 times -4 plus 2 and -4 plus 6. So order of operations, do what's inside the parentheses first. And so you end up with -4 times 3, so we end up with y equals -12. So my vertex is -4, -12. I don't think that one's too far off my graph paper. I'm going to actually do this one to scale. So I'm going to count 1, 2 spaces. There's my vertex right there. So I'm actually going to count this one out. Remember, our vertical pattern is 1, 3, 5, 7, but we are stretching that by 3. So we're going to start here at our vertex and we're going to count up 3. 1, 2, 3 over 1. And the next one should be 9 over 1. And that's really nice because that matches our x-intercepts, which tells me, yep, everything's matching, it's working. And then our next one's 15, and so it's off our graph paper. So we'll just go ahead and sketch that one in. And there's our parabola. Okay, over here on the right, first thing I recognize is that I have an x-intercept at -5, 0 and one at 2, 0. So -5, 0 and 2, 0. I need to find my axis of symmetry, and I know that that's going to be right there in the middle. But that's not going to be on a grid mark, and that's okay. So we're going to go 1, 2, 3.5. So here's going to be my axis of symmetry right there. That's at x equals a -1.5. Let me change that marker so we can read that a little better. X equals a -1.5. Okay, so we know our vertex then is a -1.5, comma, and we need to put that into our original equation and figure out what our y value is. So 2 parentheses, I'm just going to type this one into my calculator. 1.5 plus 5, close my parenthesis, and then parenthesis, a -1.5 minus 2, and we end up with -24.5. So once again, this one is off my graph paper, so we either have to rescale the y's, or I'll let you, remember, come down here. I think this one's way off, so I think I'll put it down here. I'll put my vertex right here. I'm lining it up with my axis of symmetry. I'm going to label that. You need to label it. Okay, so there's my vertex, and I know it's going to open up, so I'm just going to sketch in that parabola right there. Go past your x-intercepts. I went above the x-intercepts, so don't stop right there at the 2 points. Go through them and show that your graph is still going up. Okay, so there's that parabola. Okay, this one, find the x-intercept. Oh, whoops, I don't think we did domain and range on those other two. It wanted us to find domain and range. So domain on this one is all reals. The range is from always smallest number to biggest number, so negative 12 to positive infinity. Over here, the domain is all reals, and then the range, I'll do this. The one on the left was interval notation. The one on the right I'll do is inequality notation, is y is greater than or equal to a negative 24.5. Okay. All right, so two more. Find the intercepts and the axis of symmetry. Decide whether the graph opens up or down. Graph and find the domain and range. I might point out that every time, if you noticed, every time I wrote axis of symmetry, I wrote it as an equation. Over here, x, on the left, x equals negative 4. On the right, x equals a negative 1.5. Axis of symmetry is an equation. It's not a number, it's an equation. So you need to write it as an equation. Decide whether the graph opens up or down, graph and find the domain and range. Okay, so I know this graph is opening up because I'm looking right here, and that's a 1. So I know my graph is going to open up. This one you could think of as vertex form or intercept form. This one you could think of HK like this. So I could say it's 4, negative 4, 0. Or you could think of it in intercept form, but it's the same two intercepts. See how the parentheses are the same? So we'd end up with x equals negative 4 for this one, and x equals negative 4 for this parenthesis. So it's telling you your x-intercept is at negative 4, 0, which happens to be the vertex. So this parabola is actually sitting right there on the x-axis. Okay, so now I'm just going to go ahead and sketch that graph. It's going to open up, and it's going to go follow my 1, 3, 5 pattern. So up 1, over 1, up 3, over 1, up 5, over 1, and then we'll just go ahead and sketch that in. Go through that last point. Don't put your arrow right on it. There's room. Go through it. So there's our parabola. And then our domain on this one, the domain is all reals. And the range is the lowest point, which happens to be 0, to the highest point, which is infinity. So 0 to infinity. Okay, this one over here on the right is in the intercept form again. So looking at it, I know I have an intercept at negative 7, 0 and 1, 0. So let's go ahead and put those in. And 1, 0 right here. Let's find the middle. Right here. So there's your axis of symmetry. You're going to write that as an equation. So you're going to say x equals negative 3. So that means your vertex is negative 3. Take and put negative 3 into the original equation. And so I'm just going to type that all in one step in my calculator. So I'm going to have a negative 1/2 times a negative 3 plus 7 and negative 3 minus 1. So we end up at 8. So negative 3, 8. All right, and looking at the A out in front, I can see that it's negative and it's a half. So my vertical pattern is going to change. My vertical pattern, whoops. My vertical pattern is always 1, 3, 5, 7. But this time we're going to multiply it by a negative 1/2. It's going to be opening down. So negative 0.5, negative 1.5, negative 2.5, negative 3.5. Okay, let's graph that out. So we're going to go down. We're going to go down a half over 1. Remember, on the parabola, we always go over 1. Down 1.5 over 1. Down 2.5 over 1. And then hopefully when I do 3.5, I'm going to line up on my x-intercepts. And I do, so that's good. That means everything's matching. And then the next one would be 4.5 over 1. And that's probably plenty. And let's sketch in our parabola. Okay, and the domain on this one is all reals because the domain on a parabola is all reals on our quadratic. And the range, I'll do this one in inequality notation, is y is less than or equal to, what was my vertex? 8. Less than or equal to 8. Okay. So these are all kinds of, I mean, we know more about a parabola, but here's some of the things you know. Axis of symmetry, that's always going to be x equals a number. Your vertex is HK. If A is a positive number, you know you have a min. If A is a negative number, you know the vertex is a max. The steep or flatness of the shape, so if A, absolute value of A, is less than 1, it's a little more flat. And if A is greater than 1, that's when it's steep. That's when we stretch it. So this is our stretch. And when it's flat, that's when we're shrinking it. We always compare it to 1. And now we can find an x and a y-intercept. So remember, an x-intercept is x comma 0, and a y-intercept is 0 comma y. So we've got that. We could do domain and range on our parabolas. So those are all things we know about our parabolas. Okay, we're going to add some more ideas with graphing. So we're going to add the idea of increasing, decreasing, constant, and end behavior. So I'll start with the easier one. End behavior is describing what would happen at the very end of the graph. So that means you would be looking at these arrows, and you would be describing what happens with those arrows. Well, if I were to describe in words, this arrow on the left looks like to me that it is moving down, and it looks like it's moving to the left a little bit. So it looks like it's going down and left. That's what it looks like to me. Or you could say it's moving left and down. Okay, what about the arrow on the right? Well, it looks like it's moving to the right and up. Or you could say it's going up and right. Doesn't really matter. Okay, that's a good verbal description. What we want to do now is we want to change that into math language. So we want to do that describing what's happening in math language. So basically what I mean by that is the words left and right, we're going to associate with x's. So left and right is going to go with x, and up and down is going to go with the letter y. Okay, so I usually start with the x first. So what we're saying here, we're moving left and we're moving down. So basically, if you're moving left, what you're saying is x is going to negative infinity. I'm moving left, and moving left on the number line, going like this, means that you're going towards negative infinity. Okay, but at the same time that I'm moving left, you said that I'm moving down. So that means the y value is going to negative infinity. That's this arrow right here on the left. That's how you would describe this in math lingo. You would say x goes to negative infinity and y goes to negative infinity. Okay, so to describe the right arrow, well, when we're moving right, if you're looking on the number line, if you're moving right, you're moving towards positive infinity. So you would say, as you'd put the letter, because I need to know what letter. So remember, x is going to go with right and left, and y is going with up and down. So as x moves to the right, that's positive infinity. That's moving to the right. What's the y doing? Well, in this particular graph, the y is pointing up. So it's also going to positive infinity. So basically, you're associating the words left, right, up, down with a number. And most of the time, it's going to be positive or negative infinity. It can be something else. It doesn't always have to be that. But for mostly what we're doing, it will be positive and negative infinity. Okay, that's the end behavior. Okay, now what it was talking about, describe how the graph increases, decreases, or stays constant. So if you always start left to right. So if I start here on the left and I started to trace this graph with my finger, notice how I'm going up, up, up. So that's increasing. Right here, I start to come down. So now I'm decreasing. See, I'm going down. Keep going down. And then I get down here to the min and I change directions. And now I'm going up again. That's increasing. So this particular graph increased, decreased, and then increased again. So what we have to do is describe that. I mean, it's easy to say that in words, but we have to describe it in math lingo. So what did we say it did? It increased first, and then it decreased, and then it went back to increase. You only ever write the word increase and decrease one time, okay? So what we're interested in, guys, is the domain of where this increasing and decreasing took place. So what you're going to want to do is find any turning points or change in direction and kind of draw. It's not really an axis of symmetry, but I'm going to draw in this dotted line right here so I can see what's happening. Let's see. Does that look like that's right there on the grid mark? Okay. So what you're interested in, I've just now created 3 regions. One right here. This is one region. This is the second region right here. And then this one is the third region right here. I've created those 3 regions with the boundary lines. So that's what you're going to put for your interval of increase and decrease. So here in the hot pink region, all I care about is what's colored on my number line. Well, it looks like to me that would be from negative infinity to negative 2.5. Okay. And then it looks like I pick up again. Now it looks like the red region was where the graph was decreasing. So the red region would be from negative 2.5 to 4. And then it looks like I go back to the blue region, which is increasing again. And so you come back up to the word increase. You put this little union symbol. And we would go from 4 to infinity, positive infinity, because it's pointing to positive infinity. So when you're doing interval of increases, notice I put parentheses and brackets. This is one time that it doesn't matter. On the answer key, I might put negative 2.5 with a parenthesis around it. Interval of increase and decrease, it doesn't really matter if you do brackets or parentheses. Domain and range, it does matter. So if you're like, oh, I can't remember which way is which, just always do brackets and parentheses and you'll be fine, okay? All right, so that kind of had lots going on. Let's look at one over here on the right, our parabola, because that's the one we're going to spend the most time with. So let's do the end behavior first. I always think that's the easiest. So remember, end behavior looks at the arrows. That's why I was so particular about, oh, you got to draw arrows. You got to tell me what's the graph doing. Well, what is this graph doing right now? It looks like on the left, it's going left and down. Okay, that's nice description verbally, but we want to change that to math lingo. So moving left means you're going to negative infinity. X is going to negative infinity. And going down means Y is also going to negative infinity. That's my end behavior. Okay, over here on the right, if I were to describe it in words, it looks like it's moving right, it's moving out to the right, and it's also going down. So that's a nice verbal description, but now let's do this in math language. So moving right is the same thing as saying as x goes to positive infinity, y, as I'm moving to the right, it's going down, so y goes to negative infinity. That's describing our end behavior. Okay, now we need to describe whether it increases or decreases. And to do that, remember, we start on the left of the graph and we trace with our finger. So it looks like I'm going up. So that's an increase. Till right here, here's a change of direction. And now I'm coming down, decreasing. So it looks like to me, we're going to have an increase. So I'll put that right there. And then a decrease. So now we just have to describe that. And remember, we describe that with regions. And it's from the turning point, these little boundary lines, that dotted line that I drew in, we want to go to the left. And then it looks like there's one on the right. That's the two regions. That's the two regions that I've created with my graph. So the left side is where it's increasing. So we're increasing from negative infinity to, where's the dotted yellow line? That's where I changed my direction, and that was at 3. And then we were decreasing from 3 to positive infinity. So remember, interval of increase and decrease has nothing to do with how high it goes and how low it goes. It has to do with left and right boundaries. It's a domain value you're looking for. What's the domain where you're increasing? What's the domain where you're decreasing? Not how high or how low it goes. What's the domain in those two regions? That's kind of why I draw the little dotted lines to cut it into pieces. Okay, let's go ahead and describe the end behavior of this graph here on the left. So remember, we're going to look at the arrows and we're going to decide how are these arrows pointing. So we're going to do that in words first. So it looks like to me this is moving left and up. So now translate that into math lingo. So left is your x direction. So it looks like it's moving to negative infinity in the x direction. So I would say, here, I'll just write it down here. The end behavior as x goes to negative infinity, y is going up, so it's going to positive infinity. And now I'll describe the arrow on the right. So it looks like it's getting wider to the right, and at the same time it's going up. So in math language, that would be saying as x goes to positive infinity, that means I'm moving to the right. Y is also going to positive infinity because it's pointing up. Okay, now we're going to do intervals of increase and decrease. So to do that, remember we want to find our regions. So we have to find anywhere where we have a change of direction. So it looks like to me, here is a change of direction down here at -2, -3, right here at this point. We're going down and then we go straight across. And then same thing on this area right here. Looks like it's going straight across right there. Okay, we need those regions. So it divides it into three regions. It divides it here. It's going this way forever. Then I've got this little middle piece, and then I've got this piece that's going right forever. Those are my three regions that I'm talking about. And so when I go and describe this, and I move left to right, it looks like the first thing I'm doing is decreasing. So the region where I'm decreasing, remember, it's the domain, is from negative infinity to, where's my dotted line, my yellow dotted line, -2. Okay, and then it looks like I go constant, I go straight across. And that looks like that's from -2 to what, 1.5, 1.6, it's not, it's about in the middle, 1.5. And then it looks like I'm increasing from 1.5 to infinity. So remember, these little dotted lines right here at x equals -2 and at x equals 1.5, that's what you're going to use in your statement over there on the right. So here, this parabola, um, let's figure out right here. That's where I change directions. That's going to be at x equals -2, so that's going to be where I'm going to put that in my interval of increase and decrease statement. I'm going to describe my end behavior, which means I'm going to look at these arrows and decide what's happening here. So this one right here on the left looks like I'm going left and up, and this one's going right and up. But we don't want to use the words left and right, up and down. We want to do that in math language. So that's going to be as x goes to negative infinity, y goes to positive infinity. If I saw that, I would know the left arrow is pointing up. And then as x goes to positive infinity, y is also going to positive infinity. If I saw that statement, I would know that the right arrow is pointing up. If I didn't see it, I would know that. Okay, and as I trace this one, left to right, it looks like I'm decreasing, 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 change of direction right here, and now I'm increasing, increasing, increasing. So remember, what are our boundaries? Here on the left and here on the right. Those are the two regions. I'm decreasing on the left-hand side, I'm increasing on the right-hand side. So when I go and write that, I write it just like that. First, I'm decreasing. And I'm decreasing from negative infinity to, what was our dotted yellow line? -2. That's where the change of direction took place. And then I'm increasing from -2 to positive infinity. So remember, inside increase and decrease is not how high and low it goes. I don't care about how high or how low. I care about left to right. I care about the domain. It's the domain in the region where it's decreasing, the domain in the region where it's increasing. Okay, this is what you're going to be asked to do in your homework. So I've got this example, and then I've got some that are right out of your homework that we'll do. So first of all, you've got to be able to identify what form you're in. So I'm looking at this one, and I recognize that standard form, and I know from standard form I cannot tell what my x or my vertex is. I'm going to have to do my axis of symmetry. So I'm going to say x equals opposite of b over 2 times a. So that's -1. So I know my vertex is -1, comma, let's put -1 in right here. So if you're doing this by hand, you got to be careful with your order of operations. You have to do the power first. Order of operations say do the power first before you multiply by 2. So 1 squared is 1 times 2 is 2. Plus 4 is 6, minus 8 is -2. So there's my vertex. I know this parabola opens up because I've got a +2 right here out in front for an A, and I know that's going to stretch my pattern also. My vertical pattern, 1, 3, 5, 7, is going to get doubled. So my vertex is at -1, -2, and now I'm going to go up 2 over 1, up 6, over 1. And we're off our graph. So let's sketch that in. Okay, it says find the domain. Great. The domain of this one is all reals. It's a parabola. Range, you might want to practice back and forth using interval and inequality notation. Remember, you have to know how to do both. This one I will do in interval notation. So that's going to be from -2 to positive infinity. I'll just put the word interval over here so you know which one that is. This has a minimum point because our vertex, we usually label it, but I've already got it up there with the vertex, so we're good. Axis of symmetry, remember, is an equation. X equals -1. Right here, my y-intercept, where does it cross my y-axis? It looks like it's crossing right there at the origin, so that's going to be at 0, 0. Sorry for the typo there, y-intercept, I spelled that wrong. Interval of increase and decrease. Okay, so it looks like the interval of increase and decrease is from -infinity to our axis of symmetry, and that's decreasing. I should have wrote that word first. And then I'm increasing from -1 to positive infinity. And then the end behavior, remember, describes the arrows on the left and the right. So they're both pointing up. So as x goes to -infinity, y goes to positive infinity. And as x goes to positive infinity, y also goes to positive infinity. So the nice thing about parabolas, guys, is on the end behavior, both arrows are either going to open up or they're going to open down. That's just they're going to be the same because they go the same direction, up or down. So that makes the y part pretty easy. They're either both positive infinity or they're both negative infinity. Okay, so here's homework question number 3. We're going to answer all of those questions that we did here. I think there's one difference in that. I think this one asks for the x-intercepts. And that's easy because it's in intercept form. So to get started, that's what we start with. So the x-intercepts on this one are -1 and 3. So we'll put those in here first, -1 and 3. Well, we need to find our axis of symmetry because we don't know what the vertex is, but we can find it if we have our axis of symmetry. So there's our axis of symmetry. So let's just go ahead and write that also. So x equals +1. That's my axis of symmetry. Okay, and now we need to find the vertex. Well, we know that the vertex axis of symmetry is the x value of the vertex, and so now we're going to find the y value, and we're going to put a 1 in. So 1 plus 1 is 2 times a -2 is -4, but then you have the negative sign out in front, which makes it a +4. And that makes sense because this parabola should be opening down. It's got a negative sign out in front, so it should be opening down. So our pattern, down 1 over 1, down 3, 1, 2, 3 over 1 matches our x-intercept, so that's what we want to have happen. Down 5 over 1. We want all of our calculations and our geometry, we want everything to match. So sketch in your parabola. This is a maximum point. The domain is all reals. The range, I'll do this one in inequality notation, is y is less than or equal to 4. That's called inequality. The greater than, less than symbols, that's inequality. And then let's see what else were we supposed to do. Increase and decrease, is that the last thing? Oh, and y-intercept. Okay. So we've got our x-intercepts. We need our y-intercept. It looks like I can count this out on my graph, so that would be 0, 3. And then end behavior. That's describing your arrows. So it looks like they're both pointing down. So as x goes to -infinity, y goes to -infinity. And as x goes to positive infinity, y also goes to negative infinity. They're both pointing down, and then we'll describe interval of increase and decrease. So it looks like to me on the left, I'm starting out, because I start left to right, it looks like I'm increasing when I trace that with my finger from negative infinity to, where's our boundary line? It's right there at 1 where our axis of symmetry is. And then we're decreasing from 1 to positive infinity. Okay, here's another one. This one is in vertex form. So negative 2, 5. And then I know my axis of symmetry is going to be x equals negative 2, right? Before I even graph, I could tell all of that. So negative 2, 5, 1, 2, 3, 4, 5. Okay, my vertical pattern, it's going to open down. So my 1, 3, 5, 7 is being multiplied by a negative a half. We're shrinking it. So we're not going to go down 1, 3, 5, 7. We're going to go down a half over 1, down 1 and a half over 1, down 2 and a half over 1, down 3 and a half over 1. And that's probably enough points. We'll sketch in our parabola. Okay, on this one, we don't know how to find the x-intercepts yet because see how they didn't right here? These didn't land on a grid mark, and they shouldn't have. They don't have to land on a grid mark. So it'll tell you in the directions whether you have to find the x-intercept or not. We can't find it just yet. We haven't learned how to do that. We will eventually learn how to find that number, but not right now. So no x-intercept on this one. The y-intercept, I can do what the y-intercept is, though. I can see that on my graph. Just as an FYI, if you can't see it on your graph, because on some of these you cannot see them, it doesn't cross right at a grid mark, or it might be off your grid paper. And I did that on purpose so that you'd have to calculate it. Remember, to find a y-intercept by hand, and it doesn't matter what your equation is, you let x equal 0 and solve. So I'm going to just do, I already know what the answer is, but I'm going to just do this so you can see how that works. I'm going to do y equals a negative 1/2. I'm going to let x equal 0, and I'm going to solve that. Order of operations, say you have to do it's in the parentheses first. So 0 plus 2 is 2. Then you have to do the power. 2 squared is 4. So you're doing a negative 1/2 times 4. Well, a negative 1/2 times 4 is negative 2, plus 5 is 3. And see how we got 0, 3? So that was just like in lines from last chapter. Remember when we were trying to find the y-intercept, you let x equal 0? It's the same for every function. If you want to find the y-intercept, let x equal 0. Okay, so we've done x-intercept, or no x-intercepts on this one. Y-intercept, axis of symmetry, vertex. Domain is all reals. Range, I'm going to do this one in interval notation. And remember, we always go smallest number, that's negative infinity, to the highest number, which is 5. So make sure you're always starting with the smallest number to the biggest number. And then end behavior. It looks like to me both our arrows are pointing down, so as x goes to negative infinity, y goes to negative infinity. And as x goes to positive infinity, y goes to negative infinity. We're pointing down. They're both pointing down. And interval of increase, it looks like I'm increasing first from negative infinity to, what was my vertex? It was at negative 2. So negative 2, and then we were decreasing from negative 2 to positive infinity. Okay, that's what you're going to do in your homework. Follow the directions. It'll tell you exactly what it is you're supposed to find in the homework. All right, you're good to go.